reference tables. If you don't know what a reference table is, it's exactly what it sounds like. It's a table that other functions and pieces of code can reference, but that's just the beginning. This is a small text rendering engine that I've created in the Desmos Graphing Calculator. It lets you write full paragraphs and essays so long as you have a beefy computer. Let's take a look inside. Here you can see three functions. The first function stores the characters that you've written. I'd like to shout out MathEnthusiast314 for making these two other ones for me. This second one tells the characters where they should be placed horizontally, and the third one tells the characters where they should be placed vertically. Let's start with the keyboard and cursor. The main part of this keyboard uses what's known as list compression. I'll leave all the documentation in the description, but essentially it just makes a grid of keys that you can use. These other buttons are the side buttons, such as the spacebar, tab, and enter keys. Although the cursors look very complex, the way they work is actually very simple. The third function is what's used to delete individual characters. It's simpler than the other two. This part grabs the X position of the last character placed, and this does the same, but for the Y position. The first and second equations are basically identical, except for these variables, which I'll explain soon. This part right here, nope, not that one. This part right here grabs the X position of the last placed character that was equal to 0, or space. This does it for the vertical. This basically allows you to delete whole words by themselves. The first one is the same, but instead of spaces, it's the 39th character, also known as the period. This allows you to delete whole sentences. This is where the fun begins. Here you can see three tables, all with varying sizes. Let's start with the medium-sized one, this one. Each character has been given a number/ID. Numbers 1 through 9 all have their respective numbers as their IDs. 0 has the ID of 10. A through Z letters are ordered like they are in the alphabet, just offset by 10 because of the added numbers. The apostrophe has the ID of 37, the comma has 38, the period has 39, and the hyphen has 40. In total, there are 40 characters, which is plenty enough to write coherently. The middle table converts the keyboard's ABCD layout to the standardized QWERTY. When an input is made through the keyboard, that input is sent through this table. If the input is 5, then it will stay as 5, as you can see here. If it's A/11, then it'll come out as 27, also known as Q. Let's move on to the main event. This is a 40 by 16 reference table that houses 640 different values. Although it might seem like a lot, which it is, it's all organized and all makes sense. Let me explain. If we go down to how all the text is displayed, then we see these variables: dx1, dx5, dy2, dy4, and dc3, and all the others. These correspond to the 16 different lines or curves that appear. This works similarly to the 7-segment displays that you see at sports games, cheap watches and clocks, and your microwave. This bit right here makes the line only be displayed if it's told to do so by the reference table. If we look back at the reference, we start to see some patterns. These numbers up at the top are the variables used in the lines, and the number of rows, which is 40, is the same amount of characters available. For explanation's sake, let's just use the letter D. D, also known as 14, has two of its horizontal lines lit up, which is true. It has the top left line and the bottom left line. It also only has two vertical lines. both of the leftmost lines. And it also has two curves. Now the way the curves work is a bit weird, but it makes sense. Imagine that each character is split into 4 smaller squares. These squares are where the curves can be. If the curve's value for the character is 0, then the curve will not appear, as you can see here by this function. If the value is between 1 and 4, then it will appear. If the value for the curve is equal to 1, then the center of the curve will always appear in the top left corner of the subsquare. If it's 2, then it will appear in the top right. 3, bottom right. 4, bottom left. This graph isn't so much complex as it is just boring to make. If you want to play around with the tables and lists, then you'll find the graph link in the description. While you're down there, if you wouldn't mind, click the subscribe button. You don't have to hit the bell because I post regularly on Mondays and at 3:15 p.m. Eastern Time.